use and importance of the use and importance of data in informing all of these applications, which is why we can even have a conversation about AI and how it might inform intelligent buildings opportunities, and use that as also a way to zoom in on predictive maintenance. But to come back to the main point here, understanding who the customer is, how best to serve them, and what the actual requirements of these solutions are is quite important to realizing value in the smart buildings environment. Looking at the evolution of AI, while it has become a lot more buzzwordy and there's been a lot more hype around the artificial intelligence technologies for the past 5 years or so, this is not new. The birth of AI was actually back around World War II time, and kind of the development of the Turing test and related kind of cybernetics and early neural network applications. But that has evolved quite a bit over the past 50, 60 years. We portrayed some of those evolutions on the page. We really see our current time frame as the third evolution of AI that builds on some of the more basic reasoning and classification technologies and processes, as well as more recently business intelligence and regression and classification methods and modes of data analysis that have allowed businesses to really improve internal processes and external things like customer satisfaction and so on. The current evolution of AI is taking that to the next step, not only with the integration of many different data sources, but the ability to apply new methods of analysis to different data sets and multiple data sets at the same time. And out of that has come the more recent convolutional and recurrent neural networks and deep reinforcement learning that we'll see more of here in a moment. This provides some overviews of these different technologies, as well as some example use cases and illustrative players. Really what this is meant to say is that when you hear the words artificial intelligence or AI, there are many different things that somebody could be talking about. And it's quite hard sometimes to pick through a lot of the marketing and hype that goes on in the subject and in the news and in things like press releases and company websites to really understand what type of analysis on the data is actually happening. As I was saying, the third wave of AI innovation is largely built around these convolutional neural networks, recurrent neural networks, and deep reinforcement learning, which have taken data analytics really to the next step and improved quite drastically what can be done with different data sets. There are many different applications for these technologies. We'll look at a bunch on the next few slides here, but important to highlight is the various players that are supporting this as well. And while we've tried to highlight some players that have a focus area in the built environment itself, because the built environment is quite broad and includes many different industries and subsegments, you'll see a whole many different types of players appear on this page and the pages to follow. The last thing, so you'll see predictive equipment systems all the way on the right here under deep reinforcement learning. So we'll come back to this, but when we talk about predictive maintenance and kind of asset management systems that leverage analytics and artificial intelligence, it's not that every system or every predictive maintenance system has gotten to the point where it is truly kind of predictive and responsive to what's happening in the data. However, that is eventually where we think a lot of this is heading, especially for a lot of the most important subsystems within a built environment. We wanted to highlight use cases across the economy to set some context and then zoom in on buildings. But energy management optimization, building asset optimization, predictive maintenance, all of these can be informed by artificial intelligence and machine learning solutions. And they're likely to continue to get increasing attention in the years to come. A lot of what we've heard, or a lot of the key use cases that people tend to mention are things like automated driving, different opportunities around demand, supply, and forecasting, whether that be for energy or just general retail and other types of sales environments, whether this be true asset or process optimization in industrial manufacturing. These are some of the use cases that we tend to hear a lot about in our research and analysis. But there's so many other opportunities out here for the leverage of artificial intelligence and machine learning. And in the built environment itself, one of the use cases that we've seen a little bit more interest in, but not that many solutions around, is actually kind of establishing user environmental preferences that allow or that enable an environment to react to the way that a user would like it, whether that be lighting, whether that be air filtration and humidity, whether that be heat and cooling. All of these systems can come together to enable a user to have the environment that they're looking for to be the most productive in, or that can set the right mood even for a retail environment or something like that. So there's still a long way to go, and there's many opportunities for these technologies to evolve. You'll see sooner on the chart here, predictive and preventative maintenance, and that appears multiple times on this chart. That's what we'll be zooming in onto here in a couple slides. The other trend that we are seeing is the proliferation of these artificial intelligence and machine learning technologies towards the edge of networks and actually to on-premise environments. And so while in the past and kind of up until now and likely to continue, a lot of artificial intelligence is being done in the cloud to be able to handle these large data sets and historical data sets and understand what is happening, to really get to real-time analytics and real-time value from these systems. These types of artificial intelligence technologies and analytics techniques will need to move towards the edge. And we've tried to highlight on this page some of the examples of how this could happen, or how this would take form in some of these environments. This could be asset optimization analysis. So as I had brought up previously, the ability for an asset to actually learn as it's working. So let's say an HVAC system is, understands which days are, which times of day are warmer than others or colder than others. It can predictively optimize itself to respond to that accordingly. And that's the type of value that we're seeing a lot in the built environment today, or where a lot of players are focusing. So all of these opportunities, whether in the cloud or at the edge, are enabled by artificial intelligence and machine learning, and we've called out some examples again on the right. So whether it be that real-time sensory and environmental feedback in that HVAC example, whether it be a kiosk or a digital signage in a retail environment responding to a customer's behavior, or the actual customer themselves walking by, or whether it be video processing at the edge to support safety and security applications in these environments. All of this requires some higher level of analytics to occur closer to the edge of the network, where responses can happen in real time and value can be achieved accordingly. So bringing this back into maintenance and asset management. So for those of you who are familiar with kind of how maintenance and equipment servicing is done today, or has been done in the past, a lot of it is reactive. So if something happens, equipment fails or starts to malfunction, there's a request for a repair put out. The OEM or other service provider investigates that and eventually enables some repair or some sort of action following that. There's also in the past a lot of kind of preventative maintenance strategies or planned maintenance strategies that schedule maintenance activities no matter if the equipment is failing or not. And obviously, these types of strategies leave a lot to be desired in terms of just-in-time servicing or most efficient ways of servicing and reacting to equipment failure. And this is what AI can start to help with. So what AI and machine learning, as well as kind of the other enabling technologies associated with the Internet of Things and smart systems allow us to do is start to collect data in real time from machines and systems, analyze that data, and determine what to do all automatically, hopefully before the equipment itself fails, and drive servicing that way, driving towards no unplanned downtime, and even reducing planned downtime as much as possible. So having the data, being able to analyze that data, all enables closer collaboration, better transparency between a service provider and a customer, and overall better functioning of equipment in the long run. This is also enabling new services, and we'll get to that again in a moment. But for suppliers of these systems and other third parties, there comes a whole host of opportunities for new value and service delivery mechanisms that can both be an adjustment to the overall business model of the company, or simply be an add-on and revenue driver in the short term. Looking at asset management and predictive maintenance as a foundational opportunity here, once you're able to collect data on equipment health and status, and able to use that data and analyze that data to inform how new services and maintenance is provided to customers, it opens up other opportunities as well, as I was saying, to either inform new business models such as usage-based payment or equipment as a service types of applications and revenue models, if you will, as well as even higher value process optimization. So whether that be planning and scheduling when certain types of equipment is going to be used and how often those equipment are going to be used, whether that's managing the overall operations of the equipment and how different systems are managed in these environments, or improving processes around the use of these equipment. All of these are new kind of values that can be captured as you start to collect and analyze data coming from these systems. And so predictive maintenance and asset management, while a big opportunity in and of itself, also enables some adjacent opportunities and applications, particularly for equipment and service providers, but also for almost any sort of supplier in the ecosystem that's trying to provide new technology or support for customers in these environments. And on the customer side, a lot of new values can be achieved. So as I said, if you reduce unplanned downtime to zero, what does that do for your business? Obviously depends quite a bit on the business environment that you're in. But whether it's retail, whether it's healthcare, whether it's industrial, whether it's some data center, there's a lot of systems in these environments that are required to be up and running for these businesses to do what they need to do. And these types of services and value help enable that. What this does for these new suppliers, though, is create new services opportunities. So we've talked about a couple already, but what we're really talking about is the evolution from more basic customer support services to more real-time and collaborative and managed services with some steps in between. So as opposed to just providing simple break, fix, maintenance type of services, if you're an OEM, or troubleshooting or help desk services, if you're some other type of supplier, the ability to manage and monitor equipment and data coming from that equipment and systems in real time will enable new types of more data-driven services opportunities, as I said, that can help change business models, but also help drive more value and capture more value from these customer environments. So there's a few examples on the right here, but all of this is driven by the ability, as I said, to collect more data, to analyze that data, and to then feed that back into business processes to capture more value in these customer environments. So with that, I'll talk a little bit about some of the research that we are embarking on. But first, I'll hand it back to Greg just to give a brief overview of the current scope of this project. I'll dive into our processes and what we're up to. Greg?
Hi, Harry. Can you hear me?
Yes. Yeah.
Yeah. So yeah, I just would like to give a brief overview about this current research project, where we are now and where we're going. And so this is coming back to what I talked about at the beginning of the webinar. Is the CABA does these landmark research projects. We do 2 every year, one on the residential side and one in large building. This is the one we're doing in the large building side this year. It's on AI and predictive maintenance and intelligent buildings. And it's where CABA members will pool their funds together, and we give those funds to a research firm in a competitive RFP process, and they bid on it, and then they do a large scale research project, over $100,000 worth of research, and it's shared amongst the group of funders. And we do have an executive summary, gets shared out, it gets wider distribution out to CABA members. This is the current project right now, and these are the current funders that have committed funds to the project. A majority of them are on the steering committee. So those that are on the steering committee can shape the research, decide who's going to get surveyed, what topics are going to get covered, and what granularity they're going to be covered in. And we're having the first steering committee meeting next week for this research project, and then the next steering committee meeting at the end of July, they will be finalizing all the methodology of the research and start with the data collection phase of the research. And then ultimately in Q4 this year, probably November, early December, we'd have this final research project completed, and it'd be available to the funding organizations. And there's still time to get involved. If you're interested, contact anyone from CABA or myself at walker@caba.org. We can set up an individual call about the research project. But there was 4 bids that came back in when we sent the RFP out, and we narrowed down to the top 2. And the initial funders of the companies on the screen, they got together and they heard a webinar presentation from the top 2 bids, and Harbor Research was selected to conduct the research project. So that's where we are now, and I'll pass it back off to Harry to go a little bit more detail about what's in the proposal. And if you have any questions, you can feel free to put them in the chat box, or there's also a Q&A box that Harry can answer, or potentially myself, about the topic in general or about the research project specifically. All right. Well, with that, I'll pass back to you, Harry.
Thank you, Greg. I appreciate that description. So yeah, with what I just discussed as being a pretty high-level overview of maybe current state of things and some frameworks that might be useful to use as we look at research and analyze this opportunity, there's a number of questions that we'll be trying to answer through this research, and we'll talk a little bit about the questions first, then the process, and then the outcome. So there's a lot going on in terms of both the development of technology as well as the adoption of technology that we'll want to address or understand in the first part of this work around trends and forces. So while we've tried to characterize various applications in the intelligent buildings environments, understanding where artificial intelligence and machine learning is actually informing these systems today versus where it might inform these systems in the future, I think is first up for us. And kind of what are the implications of this for, say, regulatory and legal or socioeconomic or otherwise, and which types of suppliers are currently providing these solutions today. We'll also be looking quite a bit at customer needs, adoption, and buying behavior. and understanding kind of where customer requirements are at today, how they see artificial intelligence and machine learning technologies, how they think that these types of technologies will inform different machines, equipment systems, and otherwise in these buildings environments, and kind of where they might be focused from an investment standpoint today. We'll also be looking at kind of pain points relative to current systems and software in these environments, and use all of this as a jumping off point for understanding where these opportunities are for predictive maintenance and artificial intelligence to be effectively used in these environments. From there, we're going to try and answer some questions around supplier dynamics and best practices. So while there's a number of companies out there supplying solutions to this space, we want to understand who those companies are, what they're offering, and where there might be gaps or underserved application opportunities for other suppliers to come in. We'll also be looking at how different players' solutions are structured, strengths and weaknesses, and who we think are really the most innovative players in the market, who are leading the way in terms of new technology development and applying that new technology effectively in intelligent buildings. In terms of future considerations, we'll want to understand also where opportunities are that might not be addressed today, but could be addressed in the future with continuing development of the actual technology itself or greater collaboration amongst ecosystem participants. We'll also be looking at barriers that suppliers might face, as well as kind of overall business model implications, monetization implications, and kind of just where to focus your initiatives as a supplier to the space. From a process standpoint, we'll be conducting a survey of over 500 different stakeholders in building environments, including both tenants, operators, owners, and developers, to understand how they look at these technologies and consider prioritizing their needs and wants with regards to artificial intelligence and predictive maintenance. We'll also be conducting a number of in-depth interviews to understand more deeply customer requirements, as well as new technology initiatives on the part of suppliers, and how these two vectors are matching up to drive the opportunity. Once we do both of the initial rounds of research and the survey and the interviews, we'll also do another round of interviews to validate and drive some more detailed hypotheses out of these results that we can continue to analyze and eventually make it into this report. Ultimately, all of this will be driving a set of analyses and takeaways and recommendations for a number of key stakeholders, both the types of companies that are on the steering committee, as well as other types of companies that are present in the ecosystem participating in these opportunities. A little bit more detail on the market feedback mechanism. So on the end customer survey, we'll be, as I said, kind of targeting owners, operators, tenants, developers, anybody involved in making decisions about the types of systems and technologies that might end up in a building. And that will allow us to, as I said, get a better idea of pain points, who they look to as a key supplier of these technologies for their business and for the building itself, as well as if they are willing to pay for these new technologies, or kind of just expect them to be included in say new buildings or new relationships with their suppliers. The in-depth interviews, again, will be a little bit more broad. They will include both technology suppliers, equipment manufacturers, other types of service providers, as well as thought leaders in the space, to really understand where the market is at today and what new technology is being developed to support customer needs. All of this then results in a set of deliverables that will inform strategy and growth opportunities for the steering committee and any who purchase the report. So we are doing, we conduct regular steering committee meetings, as Greg was describing, to help us frame the research and direct the research where the steering committee and funders want the research to go. We'll also be using those calls to drive out interim updates on the progress. We will also be collaborating pretty closely on discussion guides and the survey itself, and use that to make sure that we're building understanding as we go of the research, the analysis, and what will come out. Typical deliverables for all of these assessments include both a long form report that has in the past been anywhere from 100 to 200 pages of written prose and graphs and charts, as well as individual webinars for each of the steering committee members, and a larger executive summary, or sorry, a smaller executive summary for other CABA members as well. So I hope that I hope this has been informative, and that this study would be interesting to folks. At the very least, I hope that the topic itself is something that is interesting, because I'm sure everybody who is on the call has heard about it already and will continue to hear about it in the years to come.